Imagine yourself living in a house deep within a massive, shadowy forest. For years, you have been convinced that you are the only soul inhabiting these woods. It is quiet, almost too quiet. But then, you glance out the window at your nearest neighbor's home, a place that has been dark for billions of years, and suddenly you catch a flicker. It isn't a fire, and it isn't a reflection. You see a light switch flipping on. We are talking about Proxima Centauri, the solar system nearest to our own. It is merely 4 light years away, and scientists have been catching some unusual signals from one of the system's planets. We aren't just talking about radio beeps. We're talking about strange anomalies called artificial lights that have been shaking up the brightest minds in the space community. Is there a civilization right next door? It is certainly a possibility. While older signals like BLC-1 are usually analyzed to make sure they aren't just an echo of our own civilization, a new generation of telescopes is shifting the paradigm. We are moving from simply listening to aliens to actually hearing them and seeing their cities glow in the dark. Get ready, because the James Webb Space Telescope might just be the paparazzi that catches our cosmic neighbors red-handed. Let's get the geography clarified. Proxima Centauri is our closest neighbor star. Orbiting this star is Proxima b, a rocky world roughly similar in mass to Earth. It sits right in the habitable zone, making it the galaxy's prime real estate. Things got spicy in late 2020 when a signal, dubbed BLC-1, was discovered coming from this direction. While these signals often turn out to be our own interference, basically Earth talking to itself, it forced us to ask a bigger question. Why don't we just look directly at the planets in Proxima Centauri and see if a civilization is there? The most obvious sign that someone lives on Earth is the glow from the night side of our planet. Our cities emit light that escapes out into the cosmos. Until recently, the problem was that our current generation of telescopes wasn't powerful enough to spot lights on distant worlds. It is like trying to spot a candle on the moon. But that era is coming to an end. Researchers are currently testing the capabilities of the next generation of telescopes. Specifically, we are looking at you, James Webb Telescope. The hypothesis is simple but mind-blowing. If a civilization is advanced enough or glowy enough, we would be able to see if they have the lights on. So, how do we spot a city that is 4.25 light years away? It is a game of contrast. Researchers Elisa Tabor and Avi Loeb took the Webb for a virtual alien light hunting test drive. They modeled a scenario where Proxima b utilizes artificial illumination similar to LEDs on Earth, which have distinct characteristics. Here is the math, and it is surprisingly optimistic. Tabor and Loeb found that if the artificial night-side illumination of Proxima b reaches 5% of the natural day-side illumination, Webb could detect that artificial light with 85% certainty. If they crank that brightness up to 9%, Webb's detection rate rises to a staggering 95%. Now, I know what you're thinking. 5% illumination doesn't sound like a lot. But remember, we're talking about the light from a star. Even though Proxima Centauri is a red dwarf and about 20 times dimmer than our Sun, 5% of its light is massive. It is almost like placing a firefly next to stadium lights. To put it in perspective, Earth's artificial illumination is only 0.001% of reflected stellar illumination. So, if Proxima b hosts a civilization only as lit up as us, the Webb wouldn't be able to detect it. Their lights would need to be 500 times brighter than ours. But before you click away thinking that is impossible, let me explain why it is actually very plausible. We aren't stopping with the James Webb either. The new study points to LUVOIR, Large UV Optical IR Surveyor, a multi-wavelength observatory with a possible launch in 2035. Thomas Beatty from University of Tucson reviewed both LUVOIR and HABEX to understand how they will detect city lights out to a distance of 30 parsecs. Beatty found that these future telescopes would be capable of detecting ecumenopolis worlds around 82 stars near the Sun. And here is the best part. Detecting a city-planet version of Proxima b would be easy for next-generation telescopes. We could detect just 0.5% urbanization on the planet. Why does that number matter? Because current city growth rates, put Earth at 0.5% urbanization within the next 100 years. That is literally a blink in cosmic time. If an alien civilization does exist, and they're even slightly older than us, they might have already reached this level. We don't actually know if technological civilizations are long-lived. That is one of the reasons why we do SETI, the search for extraterrestrial intelligence. Finding someone else shining in the void means there is more hope that we can keep the lights on, too. Who knows? Those lights might just be an alien beacon asking for help. But wait, how do we know we aren't just looking at a really shiny rock or a volcano having a bad day? Because artificial illumination is distinct from the natural light of stars or geological events. Scientists call these clues technosignatures. There are several ways to tell alien technology exists on another planet beyond just city lights. For example, we might see the light of a distant world waver because of a massive constellation of satellites. It sounds familiar because we're doing the exact same thing on Earth right now, pushing more and more satellites into orbit. We could even detect atmospheric pollution. And I'm not just talking about smog. We could theoretically detect the fallout from a nuclear conflict. While orbiting debris or a comet impact could mimic some of these signs, artificial light has a very specific signature that nature just doesn't produce. We aren't just looking for brightness. We're looking for a specific kind of glow that screams, "Someone built this." To understand this, we have to look at how we light up our own streets. In Thomas Beatty's models, he simulated the most common lights on Earth. High-pressure sodium streetlights reflecting off concrete surfaces. Why sodium? Because these lights feature a spectrum that is distinguishable from natural starlight. Stars burn with a chaotic mix of elements, but a street lamp emits light in very specific wavelengths. If we point our telescopes at Proxima b, we are looking for that specific color of civilization. Of course, it is not as easy as snapping a photo. In each scenario, these virtual scopes need to image planets for a minimum of 100 hours just to collect enough light streaming through the void to resolve the target. It is a long-exposure photograph on a galactic scale. The variables are the distance from Earth, the type of star the planet is orbiting, and crucially, the planet's level of urbanization. Let's talk about that level of urbanization. Currently, the Earth's surface is only about 0.05% urbanized. If aliens were peering at us from Proxima Centauri with our current level of technology, they wouldn't be able to see us. We're just too dim. But what happens if a civilization keeps building? A greater percentage of urbanization could help us see them more clearly, like, say, 100% urbanization. This concept has a name, an ecumenopolis. This is a world where the entire surface is covered in one giant city. I know it sounds super science fiction. You are probably picturing the Republic Empire capital of Coruscant in Star Wars or the ecumenopolis planet type in the strategy game Stellaris. But more than just a nerdy sci-fi concept, it is probable that an advanced civilization could completely encase their world in an unending urban landscape. If someone out there has turned their entire planet into a metropolis, Beatty's models show we could spot them around 82 different stars near the Sun. Here is the most mind-bending part of this study. Detecting an ecumenopolis on Proxima b would be easy, but we could also detect something much smaller, just 0.5% urbanization. That is 10 times more than Earth's present urbanization. But here is the thing. Current city growth rates put Earth at hitting that 0.5% mark within the next 100 years. In cosmic time, 100 years is literally a blink of an eye. This implies that if an alien civilization does exist, and they're even slightly older than us, they might have already reached this level of urbanization. This assumes, of course, that they are long-lived. We don't actually know if technological civilizations survive long enough to build planetary cities. That is the dark side of the Fermi paradox. But finding someone else shining in the void, even just a faint 0.5% glow, means there is hope that civilizations can survive their own adolescence. So why are we obsessing over Proxima b? Is it just because it is close? Not entirely. It turns out the type of star matters just as much as the telescope we use. Thomas Beatty's research demonstrates something crucial. Close-range red dwarf stars provide the best chance for detecting urban worlds. Think of it this way. Trying to spot a city on a planet orbiting a massive, blinding star like our sun is incredibly hard. The star's glare washes everything out. But a red dwarf like Proxima Centauri is smaller and dimmer. This contrast makes Proxima be currently the prime target for this kind of detective work. The math backs this up perfectly. Because of this favorable contrast, detecting an ecumenopolis version of Proxima b, that city planet we talked about, would be surprisingly easy for next-generation telescopes. We aren't just looking for needles in haystacks anymore. We are looking for a flashlight in a dimly lit room, which is a much easier game to win. But let's take a step back and ask the scary question. What if we do see lights? What if the Webb telescope or LUVOIR picks up that undeniable sodium spectrum glow? Finding someone else shining in the void means more than just discovering aliens. It means there is hope that we can keep the lights on, too. It proves that technological civilizations don't always destroy themselves as soon as they discover nuclear power or artificial intelligence. However, there's another possibility. Those lights might not just be street lamps for a midnight stroll. They might be an alien beacon asking for help, a civilization trapped on a dying world, or one facing a threat we can't even imagine, shining a massive SOS into the galaxy. We'll get to know sooner or later, but for now, we just have to keep our eyes peeled. So, we are left with the ultimate cliffhanger. We are staring into the dark, waiting for a neighbor to flip a switch. Now, I want to hear from you. What do you think is causing those lights on Proxima b? Is it a hyper-advanced civilization living in a planetary city, a desperate beacon for help, or will it turn out to be just another natural anomaly? And here is the big wager. How early do you think the Webb and other future telescopes will provide evidence? Are we talking 2026, or do we have to wait for the 2035 launch of LUVOIR? Let us know in the comments below. I read all the best theories. If you enjoyed this trip to our cosmic backyard, smash that like button like a comet hitting an atmosphere and subscribe for more deep dives into the unknown. As always, thanks for watching and keep looking up. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.